Okay, so now we've finished defining matter and mass. Let's define volume as well. And you can see over here in 11, I've said that volume is the amount of space taken up by a quantity of matter. Okay, um, and I want you to get used to the term quantity of matter, so we're going to abbreviate it QUAM. It sounds a lot more sciencey than thing or object. So when we're describing a general piece of stuff, I don't want to just call it something not sciencey. We're going to call it a quantity of matter, and that's how I'm going to abbreviate it. So if the SI base unit of length is the meter, what would the official SI unit of volume be? And remembering that volume is length on three sides, right? I've got the height, and I've got the width, and I've got the depth of the object. So it's a 3D object, and volume is going to be cubic meters. Okay, 1 meter in height, 1 meter in length, and 1 meter in depth. Okay, and this is a derived unit because it's derived from the meter, right? It's a derived unit. It's created from meters. It's meters cubed, meters times meters times meters. It's not just meters, it's meters times meters times meters. Okay, so the problem with this is that it's a huge unit. You can think of, if you hold your arms out to either side of you, like this, if you hold your arms out, that's about a meter. And if I have a meter wide and a meter tall and a meter deep, that's going to be an extraordinarily large unit. We would never, it's very impractical for the chemistry laboratory. We need something much smaller, and we're going to use something that's about a meter on each, or about a centimeter on each side, exactly a centimeter on each side, and this is a cubic centimeter instead of a cubic meter. Okay, so if we take 10 of these and line these up, we get 10 cubic centimeters. There's no special name for this. There is going to be a point to this, but if we take these and line these up, it's just going to be 10 cubic centimeters. Okay, now if I stack 10 of these 10 high, I'm going to have 100 cubic centimeters, right? I've taken my initial row and multiplied that by 10, so I've got 10 times 10, that's going to be 100 cubic centimeters in this stack. Again, it's not called anything special, it's just 100 cubic centimeters. Then finally, if I multiply each one of those planes of 100 cubic centimeters in the depth direction, I'm going to multiply 10 by 10 by 10, I get a total of 1,000 of these cubic centimeters in this box. And this is called something very special to us. And we'll talk about that here in the next slide, but this is 10 by 10 by 10 cubic centimeters, or 1,000 cubic centimeters. So this is, like I said, something fairly special. First of all, recognize that 10 centimeters is equal to a tenth of a meter. A tenth of a meter, the prefix is deci. So 10 cubic centimeters on one side is a decimeter. So 10 centimeters equals a decimeter. So this structure that we just created, we have 1 decimeter on each side, is a cubic decimeter. Okay, or we can abbreviate that 1 decimeter to the third power, a decimeter by a decimeter by a decimeter. Well, we also, like I said, call this something very special. We call this a liter. Okay, a liter is about the same size of a quart, but it's more of a metric system type of unit because it's made up of cubic centimeters. Okay, there's 1,000 cubic centimeters, but it's its own special name. Liter isn't really an official name. It's just something that we came up with because it's a very convenient volume for us. 1 liter is a very convenient volume. Okay, and we'll use it all the time. So that's where that came from. It's just a made up name. It's not part of the metric system, but it seems like it is now. So if we know that there are 1,000 cubic centimeters making up this volume, we might also call one of the small cubes a 1,000th of a liter or a milliliter. Okay, one of the small cubes is a milliliter in size. Okay, and this is so a milliliter and a cubic centimeter are exactly the same thing. So if I go on, we're going to, um, and you don't have these at home. Hold on just a second. Okay, so what we did in class, you can see in my screen down here, what we did, I have some cubes of different materials. Okay, so these cubes are all the same size, they're the same volume, but they're all made up of different materials. There's some wood ones, there's some plastic ones, there's some brass ones, there's some copper ones, and other metal ones, and they're all the same volume, okay? But if you pick them up and hold them in your hands, you can feel that some of them are heavier than others. And when we make the observation that objects of the same volume feel different in terms of their mass, what we're recognizing about one of the objects compared to the others is that they have different densities. Okay? What we're recognizing is they have different densities. Okay? So understand that if I have blocks that are the same volume, but they have different masses, that this implies a way that I can calculate or measure the density. I can say, and this should suggest to us just by doing this exercise where I have blocks of the same volume but different masses, that I can say that density equals the amount of mass in a certain volume. Okay, I don't really have to be Isaac Newton to figure this out. This is just something that should make sense from playing with these blocks. The density equals mass, the amount of mass in a certain volume. The greater the mass in a certain volume, the more dense it is. Okay, the greater the amount of mass in a certain volume, the more dense it is. So that means I have the amount of mass I have, the density is going to be mass divided by volume. Okay, so that's my formula for density. So in chemistry, we usually use units of grams per cubic centimeter. So grams per cubic centimeter or grams per milliliter. And that's the same thing, right? Cubic centimeters and milliliters is the same volume. So however many grams I have per cubic centimeter or per milliliter, and remember that's just that little cube, right? That 1 centimeter wide cube. However many grams I have, that's the density. Now, if we know the volume and the density of a quantity of matter, we could also find mass by multiplying both sides of the equation by V. And I'm going to show this here using the formula. Hold on just a second. Okay, so if I start with D equals M over V, and then I multiply both sides of the equation by V, right? I'm going to get rid of that denominator. So I multiply this side of the equation by V, and I multiply this side of the equation by V. That cancels out those V's, right? The V's cancel out, and that just leaves me with mass equals volume times density. So mass equals volume times density. And I can show that the units do the same thing here. Okay, so if I say mass is in grams and volume is in cubic centimeters and density is grams per cubic centimeter, and I multiply volumes times density, the cubic centimeters also cancel out and just leave me with grams equals grams, which is what we want, correct? So overall, I can come up with this formula that's from the density formula that says mass equals volume times density. And that's also going to be a very useful version of this for us. So let's get rid of this and go back to our Nearpod then. So if we know volume and density, then what I'm going to end up with is if we know the volume and the density of a quantity of matter, we could also find the mass. If we multiply both sides, we could say mass equals volume times density, and we'll use this formula as well. Okay, so when we talk about substances, we often notice that one substance seems heavier than another substance. What we really mean is that it's more dense if they have the same volume. One is more dense than the other. It has more mass. It has more stuff per unit of volume. Okay, so now we can say we've got a problem here. I have a block of an unknown substance that has a mass of 283.5 grams and a volume of 25 cubic centimeters. And I'm asking the question, what is the substance? And that requires you to understand that for all substances, they have their own unique density. So if I have a particular substance, there's a chance that its density has been recorded somewhere for future reference, and that I can look up whatever that density is and find out what substances have that density. And so that would be the approach here in order to find this, but that means I also have to find the density. And so we've done that in my blank workspace again and open up the solution to this. So the density problem, we've gotten our density formula, and understand that for all problems that you'll work for me in this class, you'll start by writing out the formula. You can't just write the answer down, even if it's easy to figure out. You need to start out with a formula. Then you need to substitute the values into the formula. The mass we were given was 283.5 grams, and we said that the volume was 25 cubic centimeters. And all we need to do is just divide these two numbers, and I get that the density of this substance was 11.34 grams per cubic centimeter. And so I can go online and say, hey Siri, what substance has a density of 11.34 grams per cubic centimeters? Or you could probably even just say what substance has a density of 11.34, and it will tell you that that is lead. So the answer to the solution, or the solution here, is lead. I'm sorry that we're running out of time here. We're going to have to end up going to another video. But we only have one last little thing to talk about. So let's go to a third video, and then we'll finish this out, okay, with just this last thing. So go to a third video. Sorry about that. So stop this one.